All right, hello peoples. I'm going to now go over the famous related rates problem that deals with a conical tank. Hooray! So let's read this. I'm going to take a step back because it's very long from here. A conical tank with vertex down is 20 feet across the top and 16 feet deep. Water is flowing into the tank at a rate of 12 cubic feet per minute. Find the rate of change of the depth of the water when the water is 10 feet deep. Yeah, you got that? Oh yeah. Yeah, hey guys. Hey, and they love this problem, so let's make sure that they're part of the problem or part of the solution to the problem. Let's first draw a cone, a conical tank. So going downward. How's it look? All right, that'll do. Straighten this out. Hey guys. So we draw our center there. We got line it up. Okay, so let's get some dimensions and label on this thing. So 20 feet across the top. Okay. So from here to here, 20 feet. That's going to be the diameter. That means the radius here is going to be, we'll call it R is 10. And let's go half of that, right? Now, and it's 16 feet deep, so tall. Let's go 16 over here. What the? 16 feet. All right, and water is flowing into the tank at a rate of 12 cubic feet per minute. Okay, so make sure we understand that we're dealing with the volume of the tank, of the conical tank, of the cone. So the volume of a cone, according to my memory and this math book, says that the volume of a cone is, should be 1/3 pi r squared, right? Can you find it in here, or is it? Come on. Yeah, I'm right. No, 1/3 pi r squared times the height too. Okay, that's okay. Just triple checking. The volume 1/3 pi r squared will give you the base, sort of, and 1/3 times the height. Let's box that. Now we're trying to, well, when we're saying that the volume is changing, or when it's saying the water is flowing into the tank at a rate of 12 cubic feet per minute, let's make sure we recognize that that means the volume is changing. That means dV dt, which the volume with respect to time is changing at a rate of 12 cubic feet per minute. Okay? Okay. And now we have to find the rate of the change of the depth of the water when the water is 10 feet deep. Okay, so the depth is measured by the height from here to here. The total tank is 16 feet in height, but you want to figure out what's going on with how fast is the height changing when the height is 10 feet deep. Sounds a little confusing, but it's because it is kind of at first. But let's oh, I got blue. Yeah, and we're assuming we're gonna have some water in here. I don't know if that's gonna look more confusing. Oh, does it? Maybe not. If I could draw it right. This is like the surface of the water. And going down, down, down. So then here's the height of the water. So from here to here. And we care about when it's 10. So when H is 10. Does that look good? It looks all right. Yeah, it doesn't look bad actually. Yeah. Well, that doodling in math class in middle school paid off. All right, now let's write exactly what we're trying to find. We're trying to find dH. Find dH dt when the height of the water is 10 feet deep. So when H is 10. Okay. Okay, so now we just have to find a way to represent this equation with only H's, because this R is going to make a mess. I don't make a mess, make this stuff more complicated, which you don't need right now. I have enough of, oh man, I have enough of that. Oh man. All right, okay, so let's go, let's differentiate this. Because, well, actually, no, wait, let's find a way to make this in terms of only H. Okay, so here's the thing. Okay, I got it. Here we have, let's see if we can draw this. We already have we have right triangles. So we have a big one that's fixed. So let's put this over here, the big guy, where the height is 16. Maybe I shouldn't have wrote this so big. It's taking up too much real estate. All right, so find the HDT when H is 10. So 16, the top is 10. So this part is 10. And I don't actually care about this part. You can solve for it, but who cares? I do. So then we compare it with this blue, or the blue right triangle that we can make, because this is what's going to change. This like image here, or this triangle here, will change in height, but it's going to be proportional to the big one. So the blue one, let's make it like here, is the proportional right triangle, or similar, we say, but the H is changing, so we're just going to label that H, and the R is changing. What the hell? Now, why do we have to leave it like this, or how does this help? Well, these are similar. This triangle is similar to that triangle. We can draw a squiggly if we want. So we could put R over 10 equals H over 16. Let's go over here. R over 10, what is going on with this mark? R over 10 equals H over 16. And we want to only get H's for our guy. So we solve this for R by multiplying. We get R is 10/16 H, or R is just going to be 5/8 H. So R is 5/8 H. All right, hey guys. So we plug this into here. Okay, now I haven't done this problem in a couple of years, so I was kind of freestyling it, or I got it now. It's all coming back to me. Plug that into here, and we get a volume equation for only in terms of H. The volume is, so put the 5/8 H in place of the R there. Volume is 1/3 pi times 5/8 H squared times H. So we get the volume is 8 times 8, 64, 25 over 64. So 25. I want to do this all in one shot. So 25 is going to be on top, we know. 8 times 8, 64 times 3. What is that? 120, 180, 192. 192 pi times H cubed. All right. And now this is going to be much easier and well, first off, it's possible to find the derivative of this with respect to t for h. So we can find dh dt, or sorry, we first do dB dt, and we're going to get dB dt is, this will just stay as a coefficient, 25 pi over 192 times 3h squared. Hang down low. 3h squared times dh dt. Hey guys, I'm gonna throw this away. Money. landed exactly where I wanted it to. Okay, let's break this down. This will be 75 over 192 times. Okay, well, let's actually plug and chug now. Let's all do it in one shot. Okay, so we're solving for this. We're solving for dHdt when h is 10. So we're going to plug in 10 for the h's. And we plug in 12 for dBdt. So just to save our math whiteboard so we can complete it here, plug in 12 into here. So we're going to get, let's recycle it, 12 equals, how many markers, so little time? 25 pi, or 25 over 192 pi times 3, h squared, so 10 squared, or 100, times dH dt. And we're going to solve for dH dt here. All right, so we're going to get 3 times 100, 300 is be 300 times 70, 25. Damn, it's getting huge. That's what, never mind. That's what she said. 300 times 25. What is that? 3 times 25, 75, 750, 7,500. Am I right? I think I am. 300 times 25. Yeah, 7,500. Of course. 12 equals 7,500 over 192 pi times dH dt. And then we're just going to multiply this. Just do the math. So we get 12 over 7,500 times 192 on top over pi equals dH dt. So using some calculator action, 12 times 192 divided by 7500 pi 0.09778497. Yay! Let's write this. Where am I going to write this? Let's write it up there. Let's use the red marker. Let's use a brand new fresh one. This one's dead. Calculator. Okay, so going done, we'll get 0.097784,797. And then what are we dealing with? Cubic feet per second, because it's just one dimensional. Feet per minute, actually. It's going up by that much. And that's it. That's our answer. All right, so I hope that helps. It actually helps a lot. Let me know if any questions. Feedback is always appreciated. I know I'm got a lot to improve on, but feedback is if done positively is great. And subscribe, tell your friends, tell your parents, tell your enemies, tell everybody. And I'll see you guys later. Thanks for watching. Bye.